I'm Anil Kumar. It is time to prepare for test. We have seen many examples and understood the concept. Now here I've taken up questions from previous test papers. Most of them are from IB senior level maths. This one is on normal distribution. Let us explore and understand how to solve these questions. Some of them can be very tricky, as the one which we are going to solve in this particular video. This question is, the scores on a test are normally distributed. 30% of students score less than 108 marks on the test and 20% score more than 154 marks. Determine the probability that a student will score more than 160 marks. This is an excellent question. We are actually not given mean or standard deviation, and we need to solve this question, right? So those who are using calculators may find it very tricky also. Okay, let's try to understand this question. Read it once again. It says, the scores on a test are normally distributed. So we're talking about a normal distribution. And as I said, we really don't know the mean and the standard deviation in this case. But we know 30% of students score less than 108 marks. This is what we know. So number of students scoring less than 108 marks is 30%, which is 0.3. So this could be translated into an equation. So let's write down one equation, which is the random variable takes a value which is less than 108 and its probability is 0.3. So we have defined our random variable as the mark score. Okay, I have not written that, but I hope you understand, right? So the random variable x is the marks. Okay, so if the value of marks is less than 108, its probability is 30%. This is one condition we are given. And the second is, and 20% score more than 154. So the probability for greater than 154 is 20%, which is 0.2, right? So that is greater than, right? So we got two ends, less than and greater than. Now the question is, determine the probability that the student would score more than 160 marks. That is what we need to find, more than 160 marks. So before finding that, we need to find what is the standard deviation and the mean, right? But these two equations will give us two equations to calculate that, what we want, correct? So I hope you got the strategy. So at this stage, you can always pause the video, answer the question, and then look into my suggestions. Now, what I have actually is tables. So we have these standard normal distribution tables where we are given all these values. So whenever you have a table, you have to see what the values represent, right? So table values represent area to the left of the z-score. So from the left, we have the z-scores given. So if I look for 0.3, so 0.3 is kind of here, somewhere at the bottom of this page. So 0.3 is kind of here, in between these two values. So it is minus 0.5. You could take 2, right? So let's take 2. So we'll work with minus 0.52, which is 0.301, right? So we'll take this value. So minus 0.52. So this is z value of minus 0.52 from the table we just checked. Is that okay? So that is what we get from the table. Now this greater than, I will have to convert to less than. Only then I can, find what the z value score is. So what we'll do is we'll kind of write, since the table which I have, which you will also have, will be either from the left side or from the mean, right? So even then you have to change this, okay? So less than 154 probability will be 1 minus 0.2, which is 80%, which is 0.8, right? So now we have to look for z-score, what value of the z-score should be so that we get 80%, right? So that is more than 50%, so we'll go into positive values this time. So 0.8 is what we're looking into. Okay, so 0.8 is where? So you could take 0.7995 or 0.8023. So let's take 0.8023, okay? So which is 0.85. So 0.85, okay. So we are saying less than 0.85 z-score for giving us 80%. Is it okay? So what we have got is, from the given information, the z-scores. Now can you do it? Yes, I think you can. You can pause the video, answer the question, and then look into my suggestion. So from solving these two equations, z-score is this, then probability is 30%. If that, then it is 80%, correct? So as you know, what is z-score? Z-score is x minus mean divided by standard deviation. That's the formula which we are going to use. Z-score is minus 0.52. We don't know what this x is. We know, which is 108, right? So we don't know what mu and sigma is in this case. It's kind of different from previous ones, right? So x we know this time. Okay, so 108 minus mu over sigma. That was the whole idea, right? Two variables to be found. And in this case, it is 0.85, which is the value of z-score. That should be equals to 154 is the value of x minus the mean divided by standard deviation. Correct. So that is what we get, right? Now we can rearrange and then find the values. So we can write this as it's like solving two equations. So we'll rearrange. So it is minus 0.52 sigma equals to 108 minus mu. And in this case, it is 0.85 sigma equals to 154 minus mu, right? So let me call these equations as equation 1 and equation 2. Okay. So what I will do now is I will do equation 2 take away equation 1, right? So if I do equation 2 take away equation 1, then on the left side we get 0.85 plus, because that becomes minus, right? So plus 0.52, which is equals to, in decimals, 1.37. So we get, or let me do it in 2 steps. But I hope you've understood, right? So what we are trying to do, okay, let me do it in 1 step. 1.37 sigma equals to. So the idea is, if I do equation 2 minus equation 1, then the mean value mu will cancel, right? So we are having only one variable which we can find, right? So on this side, 0.85 minus 0.52, we'll add them up, right? And on the other side, we have 154 minus 108, right? So 154 minus 108, which is 46. We get 46. Is that okay? So this is what we get. And from here, we get the value of mean, which is 46 divided by 1.37, correct? So we'll divide 46 by 1.37. That gives us, in decimals, 33.57, okay? So 33.57 becomes the value of sigma. Is that okay? So that is how we find the value of sigma in this particular case. You could round it to, let us say, 33.6. Okay, that becomes sigma. Once you know the value of sigma, you can place it and find the mean, right? So you say mean is equals to 154 take away 0.85 times the sigma, which is 33.6, right? So we'll find the mean now. So the value of mean is 154 take away 0.85 times 33.6. In decimals, it is 125.44, right? So we can round this also. Okay, so we'll just write, okay, 125.44, we'll just write this as 125. Maybe 125.4, as you wish, right? So that is what we get, right? So that is the mean. Now it says, determine the probability that the student would score more than 160 marks. Correct? Now, since now we know mu and sigma, that is to say mean and standard deviations, we can actually find for this the probability, right? So we want to find the probability that the student will score more than 160 marks. So now let's calculate that part. So we have a normal distribution. So now we want probability that the student will score more than 160 marks. That is what we need. With the known sigma and mu, we could translate this to z-scores. We say probability that the z-score is what? Is greater than, we'll write this now in terms of z-score. So the marks is 160, take away mu value, which is, let's say, 125, let's keep it 5, okay, since we are writing this in one decimal place, divided by the sigma, which is 33.6, right? So that becomes the z-score. So we are saying probability that the z-score is greater than, we can calculate this value, correct? So it is 160 minus 125.5 divided by 33.6. That gives you in decimals 1.026. So that is what we have, right? So in z-scores, what we are doing is we only check two decimal places, correct? So basically we'll see what is the probability that the z-score greater than 1.03, let us say, okay, right? So we'll get back to our z-score tables. Okay, here we are, 1.03. Okay, when we are saying greater than, we have to actually translate to less than, right? Then we can use this. So we'll find for less than and then get the value. So from the table, since my table is less than, so and then we'll do, so that is equals to, we will write this as 1 minus the probability that z-score is less than 1.03. Is it okay? So we'll do this. So we'll write this as equals to 1 minus the z-score. Okay. So let's get back to this 1.03. So 1.03. So this is 1.001, 2, 3. So that's the value. 0.8484. Okay. 0.8484. So it is 0.8484. That is the value, right? So let's use the calculator to figure this out. 1 minus 0.8484 equals to, in decimal, 0.1516. So that is 15%, right? So that is the answer which you get, right? So the probability, determine the probability that the student would score more than 160 marks. So in this case, the answer will be 15%, right? So the answer is around 15%. Is it okay? So that is how you're going to solve. So it's a very tricky question. Go through it in details to understand how we really got it. I'm Anil Kumar, and I hope that really helps. You can always share and subscribe my videos. You'll find complete test papers solved in my videos. You may have to search a bit. Thank you and all the best.